Um, cool. Yeah. I mean, thanks for the introduction. It was already leaked that I'm a consultant. It's a confession. I never intended to be, but it so happened. Um, that's not a bad thing. I'm also a developer and a tech lead on my current project. That always changes in ThoughtWorks, the organization, depending on the project that you go to, depending on the context. Um, so that's what I do at the moment. Being a consultant or a consultancy, I have to say, we see a lot of hype around microservices. So I guess that's the starting point for what I'm going to talk about. Like, where is this hype coming from? Why is this a thing that everybody all of a sudden wants to do? And is it something for you, or what's the prerequisites or constraints even that you get with them? I'm currently working on a greenfield microservices project, which is kind of maybe an anti-pattern to begin with, but I'll get to that later. And that's really exciting because I learned a lot about how to actually set this up, like how to carve out your services, how to discover them even, how to set up your teams, what does technological diversity actually mean, all these things that you sometimes don't get to really see develop that much when you're in an existing system, right? So I'll run you through the promise of microservices, what they conceptually are, just to give everybody the chance to be on the same page, and then the implications and maybe when to avoid them. I also took over from Nina, who was supposed to run this talk in the first place, and I'm really happy that I can be here, but I also want to shout out to her. Thanks so much. It's really cool. I stole stuff from her. I also stole stuff from people like Sam Newman, and Martin Fowler, and all the go-to people. So that's you'll see that probably some of the things you may have already seen before. So why the hype? Organizations nowadays expect business agility, like everything that's around speeding up time to market, responding to changing requirements, which is notoriously not something that software systems were really good at, or IT organizations, or wherever you want to source that from. But their reality is that the market competition really moves faster and faster. And also at the same time, software has become the backbone to their business models often, right? So these things have come closer together, and also there's more and more speed in this. So there's no more time for long, strictly orchestrated release cycles and all the things that we know from, former days maybe, or even today often. We also need continuous experimentation because we often don't really know what are the systems that we're building. What should they look like? We usually have a starting idea, but then as we go deeper into them, we discover that there's much more around them than what we thought. And rewrites that we've seen are really, really expensive often, especially when it comes to big systems. So I guess the hype is that we all hope that with microservices, we can embrace change and evolvability. And those are the main ends that often microservices architectures are followed or are introduced for. So as I said, that's not necessarily the hallmark of software systems as we know them. We see people being more and more frustrated about them, especially as we're getting more and more traction with like deploying to clouds and all the self-service opportunities in them and the speed that they can also bring you. But the complexity of some monolithic systems are much, much larger than what fits in people's heads, right? So as a single developer, you get onto a project and it takes like a year until you onboard. I've heard that at clients, right? That it just takes a year until somebody can actually productively work on a system. And that alone, of course, is a huge investment. Over time also, tighter coupling just happens if you have one big monolith. And I'm just taking the monolith. I know there's more different architectures out there, but just as like, to contrast the things. So tight coupling just happens, right? Because you have the opportunity to just call this other component directly, or to just call even the method inside this component. And sometimes you have to, because you can release stuff, but you cannot be sure that they will, be able to fit something into the next release themselves. So these things just happen. And sometimes it's just a pragmatic choice of a developer or a team. We also see lockstep deployments often, what I just kind of noted at the site is that you cannot just release components. You always have to wait for this big release management thing that happens, I don't know, every few months or even, longer than that. Yeah, and then I guess the last big thing, there's more of those, but the last big thing that kind of like brought us into the situation is that with that you can also not scale individual components to their cross-functional requirements, right? Like whatever it is that you want to optimize for. So you always have to actually scale the entire system, and that's not always easy, and that's also not necessarily fast to do. So Sam Newman wasn't the first one talking about microservices, but he says, microservices are small autonomous services that work together, modeled around a business domain. So the central idea of microservices is this idea of high cohesion and loose coupling that we all know from like software development, right? I mean, it's one of the good software design practices for a long time, but they kind of take it to the next level by really decoupling functionality into separate processes at the end of the day. So for those who do not know what that means, high cohesion is the idea of keeping similar things together, stuff that changes together, stuff that's more related, and loose coupling means like the stuff that's not as closely related. You do not want to interdepend too closely, so they shouldn't necessarily change together. So that's the idea of componentalization, and you can do that in many different ways. And before microservices, there was also this idea of service-oriented architectures that some of you may have seen or known before. Some people call them a bit of a failed architecture in a way. The basic idea, though, is the same, right? Like you want to identify those components and then just separate them potentially through network calls or something that's just more clearly decoupled and put them in separate processes. There's a couple of learnings from those systems that have made it into what the microservices architectures should look like today, or maybe what this community, or I don't even know what to say, like people that are working on them have tried to incorporate into the descriptions or the patterns or the principles of microservices architectures. So one of them is, even though we have made them smaller in service-oriented architectures, services are still usually too big, so their granularity still spans a lot of functionality. There's this big thing about smart pipes, like we've seen enterprise service buses that encapsulate so much logic that the end services actually using them don't really understand what's going on, which makes it a lot harder to actually then develop on those endpoints. Hello. Sometimes you even had coupling as to a degree that you had business requirements that span across different services in a service-oriented architecture, and that makes it like increase or inspires the necessity of them then being deployed together eventually again. And then before during that time, the idea of reusing stuff was pretty big, right? Like the idea was we can go so much faster if we just reuse stuff, right? Like if they build something and we need something like that, then we'll just build a component that does this thing that we all need. And that kind of turned things upside down, because sometimes you could even get the feeling that people weren't using stuff anymore. They were building for reuse, right? And then you optimize to a different end. So this I stole from Martin Fowler. Just maybe in more detail. So we said a monolith, and this is just to contrast again, a monolith puts every functionality into one big process, while a microservice tries to put as much related functionality together in a very small piece, and then in its own process, so it can run in its own thing. That then means that when we scale, we always scale the entire system for a monolithic architecture or system, but we can actually scale the stuff that we need to scale in a microservices architecture. And we can also deploy those things individually, right? Like whenever we need to, we can go out, push it out, and then it's just going to be there. There's other ways to for decomposition, other techniques. I guess we all know libraries, we're using them all the time. They run in our process though, so they're a different thing. That we have the idea of modules. Some languages are better in those, others are not. That helps with decomposing your systems, but then still they run in your own process. So I guess the main idea is as long as the components live in the same process, coupling will happen. So this is just a glimpse on what a microservices architecture really like on a very high level often looks like. Often we have verticals that are directed towards some sort of business domain. Inside those live services. Some are front-end services. Some have their own like backend for front-end. Some are just like providing backend logic. Some require database. Some don't. They do need to communicate though. So sometimes they always communicate through an API gateway to decouple. I think that's like more or less a standard-ish thing, but maybe you can tell us more about that later. So, and then inside a vertical, I mean, also this is highly discussed, but you often see asynchronous communication happening between services because you say they kind of belong closer together than to the rest of the world, so they do have a bit of a different way of communicating for all sorts of reasons. Just as a glimpse. So microservices don't only come with benefits, they also come with cost. Some of the benefits we've also already mentioned, those module boundaries or system boundaries reinforce loose coupling because you just cannot directly call that method in this other component. They focus on independent deployment, so you can basically deploy whenever you like in an ideal world. And they also help you with technological diversity, which means you can pick the right tool for the job. But with this distribution, there comes a lot of overhead. Remote calls are slower. They're less resilient than when you're in your own one process. If that's up, it's up. If it's down, it's down. In this case, it's a lot more complex. And it's also a lot harder to reason about. Like as a developer, you always have to like play with that idea in mind, like, you know, there is the internet in between that has all sorts of implications, be it security-wise or just, you know, availability-wise. You also have to live with the concept of eventual consistency. So a lot of developers that are around for a long time have been trained on this like idea that everything has to be really, really consistent all the time. Like I have this one source of truth for all my data, and it's always going to be like that, and there's no other truth and never anywhere in the system. That just doesn't work with this kind of architecture. And of course, you get operational overhead, and they're like this operational complexity that you get because you need a lot of things to run your service, and then you need this like, I don't know, 100 times, depending on how big your system is or how many services you run. So they're much more difficult to operate. And that's also a reason why often DevOps is a thing that kind of develops alongside the idea of microservices. So a lot of the organizations that I've seen starting into this journey of microservices have then also started reinforcing this DevOps culture and the idea of it. Infrastructure automation and all these kind of things. So you need a pretty mature organization to do this. And I think Martin Fowler once said you have to be thus tall to do it. I still don't really understand what that means, but I think it's around that. So now the question is, how do we get those things right? Right? I mean, there's all kinds of pitfalls, and I think Sam Newman came up with this idea of like collecting all the learnings, or at least the learnings that he saw, into some principles that we just need to really get right in order to hopefully get less of a pain with the microservices architecture. And the first one is do model around a business domain. So we've seen this all comes, or is a lot driven by business requirements and the change in the market and all that kind of stuff. That doesn't help you if you then, like, once a requirement changes, you have to, like, you know, work on all these systems or all these different services, right? So you want to make sure that you eventually find services that are carved in a way that teams can actually end-to-end work on something, or that you can actually, they can basically build a business requirement by not having too many points of contact for that. So the idea of separating along technical lines, which was often something that we saw in service-oriented architectures, is a bit of a pitfall. So that also means that a lot of organizations nowadays start off with domain-driven design as like the first kind of drafting board for this. We have to say, though, that you wouldn't probably get it right in the beginning. No matter how well you know your domain, you'd probably get it wrong in the beginning. So you have to be prepared that these may change. Probably some will change. And this brings in the idea of evolutionary architecture, and why people around evolutionary architecture say microservices are a good fit for this idea of not drafting everything out in the beginning, but really start somewhere and then drive and find out what the principles are that you actually need to protect in your system. Conceptual models differ. Depending on how you look at a certain requirement or a certain component, I would say better. It really depends on how you look at it. Given you have the concept of a customer in the sales world, so everything that deals with sales in your system, a customer is probably someone that you want to sell something to. Then when you go into the more, like service side of things, like if you go to support or functionality that deals with these things, you probably have someone who complained, or you have someone who raised a ticket. It's a very different person. You need to know very different things about this person. So the conceptual models of people working in those teams are different, and the conceptual models of this piece, of this component, are very different. And I think this is also something that maybe some people have seen, also in service-oriented architectures, but especially, of course, in monolithic systems. You often find these huge Oracle databases that have this like massive schema. Like, I don't know who understands. Some people do. I'm always really intimidated by the people that understand those things, because they're super complex. They're highly normalized. Like, they're nothing real to a normal person like me. But they are that way because all those different conceptual models integrate with them, right? They need to kind of like reflect that. Or the other way around, all those services need to take the schema and somehow fiddle around with it so it works for their domain. And that's a lot of work, and that leads to a lot of misunderstanding. That leads to a lot of really weird table names. And so that's a pitfall that you definitely want to avoid. And then there's Conway's Law, which says any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure, which basically at the end of the day says, if you have an organization and put people closer together in some part and further away in another, because they just physically have to be in different locations, they can't possibly all sit in the same space, the systems that you are going to come up with reflect those patterns, right? Like who talks to whom and who knows what about what, and who knows the conceptual model of the other team or that team. And so that's what you get. You can leverage that in a microservices architecture by turning it upside down and doing something that's called the inverse Conway maneuver. We're thinking about those boundaries and then putting the teams together, or the people together that actually should be working together on this, like have the same conceptual idea. So the next thing is a culture of automation. You really need to drive that culture of automation and basically automate everything in your systems. and across the systems. And that is mainly because everything scales. So usually you see organizations starting out with a few services, and then they discover more, and even teams discover stuff that doesn't really belong to their domain, but to something else. So you get more and more and more services, and they sprung up, and it's really kind of like a hockey stick thing. All of a sudden you have like all these services. And if you do not get the tooling right in the beginning to actually automate, I don't know, test infrastructure, deployment infrastructure, continuous integration, all these kind of things, then you'll have to deal with the little bit of manual work that was there in the beginning, but 100 times, right? Because you have all those services and you have to do it over and over again. So we really want to make sure, and it's also one of the reasons why DevOps is an important topic in microservices architectures, you really want to make sure that you automate as much as you possibly can. Hiding implementation details. This kind of, this whole tight coupling or loose coupling, high cohesion thing comes back over and over again. You want to make sure that the services that you have some internal knowledge about whatever it is that they're doing, and then communicate whatever is the output of that through public APIs. But really make a difference between what is it that I do internally and what is it that I share. And how much do I actually want to expose stuff or not? Because everything that you expose once, it's really hard to take back. So you really have to think about that. You want independent replacement. And if you have too many of those or too much of that shared knowledge, then it gets harder and harder to exchange or replace one service. Because you don't have a few connection points, you have many of them. And then there's the pattern of change, and I spoke about this briefly before. You want to keep things that change at the same time together in the same module, because then they have the same reason for change, and we know this from object-oriented software design. The same reason, or one reason to change, one system. Then also, you have differences in how often something changes, right? Like how often you get new requirements. Something that changes more often is one service. Something that changes less often is potentially another one. Always keeping the business boundaries in mind, right? But from a technical perspective. Same thing about cross-functional requirements. If you have a system or a service, and all of a sudden you realize that you've introduced this feature into your service that requires a dramatically different availability or dramatically different load that it has to handle or stuff like that, right? Then you may want to think about splitting this out, because then all of a sudden you focus on too many things at the same time, and maybe this thing has different characteristics, so it may go somewhere else. Decentralize all the things. We talked about this idea of like sharing or reusing things. That's not a bad thing in itself, right? It just shouldn't be the driver of what you develop. So opposing to that, a lot of people working with microservices have found that harvesting and sharing is a lot of a better approach to reusing stuff or doing the same thing than standardization or reusing components as such. So you do want to exchange and you do want to harvest what you're learning, but you do not necessarily want to share stuff. Like share as in using the same component. You want autonomous teams that are able to make decisions by themselves. They should be enabled to do it by the business side. They should be able to also, as much as they can, handle something end to end, so they can actually get some real feedback and drive like all the agility and all that kind of stuff. You want smart endpoints and dumb pipes, basically building on the idea of the internet, which kind of works well and scales fine. That's the whole discussion about the enterprise service bus that we mentioned before. And you want to give people the opportunity to use the right tool for the job. And that also means that there's a lot of change in technology. Like there's a lot of new stuff that we can leverage. Like Docker wasn't a thing a few years back, right? But it's a thing that drives a lot of new systems nowadays because it's just so handy. And it makes things a lot faster and a lot easier to do yourself. And when you have a system that's highly decoupled, then you can introduce new parts of the system that can leverage those new technology. Or they may even just do different things, so they need a different language to be written in. This all goes with the note that you still need to be one platform. You need stuff that you share. You need an orientation of building the same thing. And there's some ways of exchanging learnings or common direction that I've seen work. So one of them is something like this. The content isn't as important. It's more the structure, right? So what we often see is there's an architecture decision board, and then they make architectural decisions, whatever that is. And then they come over to Teams, or they hand you a document like this. It's like, read it, and then do it like that. That usually doesn't work too well for many reasons. A lot of them are like just the differences in what people actually do and what they need. So what I've seen work instead is together with the people actually developing stuff, defining a thing, or like finding those patterns or finding those principles, what they're often called architectural principles, through a discussion. They start with more of a business perspective, like what is it that we want to get to? What are the key characteristics that we want to drive? And then you go to what does this mean for our architecture? So what are the big principles that we agree are important for us? Like often you see something like share nothing, or you see AWS first, or stuff like that. And then from that, you can derive more concrete design and delivery principles. Like saying, okay, if we want to reduce time to market, we probably need to eliminate all complexity that we don't necessarily need. We probably need to make sure that people that are actually working on those services run the services themselves so they know what it means to actually have them in production and can react to stuff, can change if it fails, stuff like that. Another thing for more around sharing knowledge, and this is probably because I'm from ThoughtWorks, so I'm being brainwashed with this stuff all the time. But as a company, we do something like a tech radar. And the tech radar actually started as a thing that was meant to share information across an organization that spanned several continents and had like a few thousand people. And we're like, okay, we're making all those experiences in all kinds of different contexts. How can we leverage that better and share it better in a somewhat systematic way, but not as like a thing that we give people so it's their Bible. So we're doing this fairly often, like 3-4 times a year. Now we collect from all our project teams what they've seen work and what they don't, and then a crew of people that know lots about technology, put it all together and bring it into this radar form. Now, for a few years, we've also seen our clients asking us to do something like that with them. And I think it's really, really cool, especially if you have a bit of a decentralized structure or just big teams, that you just bring them together and share, what works for you in your context, because what works for us or in what we see doesn't necessarily have to work for that specific context. So we're then building this radar with them. The next one is deploying independently. Nothing new. We've spoken about this a little bit, but it's really as important as having like a separate slide for it. So you do want to be able to go to production with your service without having to change anything outside it in an ideal world. You want no surprising side effects. That's also why often Docker is a great thing for this, because you can just have this one host per service thing. You don't even have to think about it much. You also want to make sure, of course, while you do that, because that's the only way that you can do that you know what happens with going live, with the contracts that you have with other services. So one thing that I often see is consumer-driven contract testing. I know if people have done that. It's a really smart idea to actually say, the consumer of my API, and I always have to concentrate because I'm always getting the producer and the consumer wrong. The consumer of my API gives me a set of things that it expects from my service, right? And then I take those things, and they're a test. They're like an automated test. They give this thing to me, and I run it in my CI pipeline. So whenever I deploy, or even before I deploy to live, I deploy to non-live or wherever, once I've built my service, I check against those criteria, against those tests. And when they're green, I can be pretty sure that I'm not breaking the other side. They're a really cool tool. And they actually don't have to be packed or anything like big tooling. They can just be really simple. They can be just, a Docker file that you get with a little service running that just runs those tests for you. You can take all the work off the producer and just do this as a consumer and then give it to them and they run it. And they're a placeholder for 4 conversations. If I realize that I break something, that doesn't necessarily mean it's wrong. So I can walk over and say, hey, I've done this thing. It seems like it's not working anymore. Can we talk about this? And then you figure out what's the best way to manage that connection point. Sometimes that's also because you're not always as tolerant to what you're getting as you should be. So you should be as tolerant as possible to what you're receiving, and only really go red when something breaks that actually affects what you need to really need to consume. And then there's this business side also. They then sometimes say, oh, we're going live with all those features all the time. We really want to do a marketing campaign. And then you're like, oh shit, I can't stop to deploy because this is the whole heartbeat of my process of my go live and this non-event of releasing. And then you can use stuff like feature toggles or something like that. So you can say, well, I'm deploying it technically. It's there. I know it works, but it's not necessarily visible to the customer. Consumer first. In a services architecture, not necessarily only microservices, but whenever you have individual components, you have to drive product mentality through all your teams. They all need to own their systems. They all need to be aware of what are the metrics that drive my system? What am I developing them towards? How do I learn from feedback? And that can mean I have a UI and this is actual real customer feedback, but it can also mean I'm just providing an API and then I still need to learn from the adoption of my API. If I'm building something, nobody ever uses it, it may be useless. Or I'm doing something wrong. Or maybe they can't even find the service because they don't know where it is. There's so many of them, right? How would they discover it? I don't have good documentation, all that kind of stuff. And then there's the whole idea of you build it, you run it. So when it breaks, you're responsible for the thing to go back up. You're responsible to fix it. And not through multiple channels or some sort of ticketing system that just brings it back to you. That will always still happen. But really, you need to be actually actively looking out for these things. Isolating failure. So failures can super easily happen when you have all these processes that you need to maintain, right? Something can always be down. It's not just one thing you look at, it's 100 or 150. So stuff can just go wrong all the time. You're expanding that surface of failure when you create an architecture like that. And that, the multiplicative effect of downtime, basically just says, if I have an availability of 99.9%, which is quite a bit, that makes up for roughly 44 minutes a month, which can just be small things, so you wouldn't even necessarily notice. But if I now have 10 services that all have this 99.9% of availability, this can make 7 hours and 20 minutes, which is a different thing. And 10 services aren't many, right? There's usually much more than that. Of course, this means in a synchronous world, right? That's why asynchronous calls are a thing that a lot of microservices architectures leverage, especially for this. So you kind of decouple yourself a little bit from the fact of this other service being there at this specific moment in time when you call it and you need that data And then if it's not there, you cannot display the price of a product or something like that. That would be really sad. You also need to make sure that you're resilient, like as the service consuming this other thing, you need to be resilient for these things to happen. So asynchronicity is one thing, for example, to do. Circuit breakers are a different thing. ACL is a very different thing. Like you want these anti-corruption layers that help you buffer some of the information that you need, right? Stuff like that. You need to actively think about that. You want to build for that resistance, and that means you want to actually find out what happens if something goes wrong. So probably some of you know about Simian Army Netflix Toolbox. It's a really cool toolbox where you can just say, okay, I go in and on a Tuesday morning, as opposed to a Saturday night, I just bring down this whole AWS region and then see what happens. And they even do it in their live environments, right? Which is kind of scary sometimes, but this is actually what you want to know, right? When I bring this down, can my system react and just recover from that problem? Or even not go down, in the best of cases. So yeah, I guess the main message is something will go wrong, and you have to identify it. Better you do it on a Tuesday morning than on a Saturday night. The last thing kind of derives from all that. It means you have to be highly observable, or your systems have to be highly observable. That means you need to understand when something goes wrong. You need to see where it's going wrong. You need to see how bad it is. You need all kinds of monitoring. You want to aggregate logs also across services, potentially for the entire system. So, sometimes you don't really know where does this problem actually belong to. You want to monitor your technical metrics, but also business metrics. So you want to know, how many requests per second is my database receiving, but you also at the same time want to know how many orders do we actually get through the system, because you're responsible for both of these things. Semantic monitoring is a good thing to do too. That basically means the tests that you run before you deploy, you take them, you run them against, or not all of them, but a subset of them, run them against your production system over and over again, so you early detect things that go wrong. And you already have those, so you can do this fairly easily. And that triggers the team that's working on the service directly, and not someone somewhere in the food chain, and then it comes around at some point eventually. Now, if you have a decentralized system, debugging can be really, really hard, because something goes wrong out there, and then where did this problem even start, right? So a lot of QAs that I've been working with, they really push for the idea of correlation IDs. So you can say, okay, I see in the logs this thing went wrong, and then I go through and I find this ID over and over again, and then I can maybe find it somewhere else in the system where it actually belongs, and somebody can actually do something about it. Cool. So I think the last thing for me to say is, are they for me? Like, what do I want them now? Are they too complex? Are they good? And I guess the answer is it depends, right? You want to look, so what you can gain is productivity, but also against the understanding that you also get base complexity in the beginning, right? So if you have a not too complex system, you probably get yourself into more of that base complexity by having to manage all that overhead. And you never really get to the point where it saves you so much complexity that you gain productivity for it. So it's really, you have to find out. And that's only the one side. The other thing is, like from all the things that I've been talking about, you also need a really, really mature IT organization. Not all organizations can do this. Like especially huge, very big ones often start out with a very new, like what we're doing, right? Greenfield approach to things, because they know this mindset is very different of where they're coming from, and it's not easily transferable. People don't just do this differently from one day to the next. So you kind of also have to manage this transition, and if you have a big organization, that's a lot of work. If you have a small organization, maybe upskilling people or just, getting this culture up is a lot easier. And that's it. Thank you.